Alright, so today we're going over a review of derivatives. So this is essentially all derivatives in calculus, besides, of course, stuff like Al-Hoffman rule, some of the theorems. But basically, we're going to be going over the product rule, and then we have the quotient rule here, the chain rule, and then log and ln derivatives. So these are all the formulas for them. It's a good note to memorize all of them, because you will be using them. So let's move on to the questions. Right, so let's take a look at number three. So number three is function g of x is equal to 4x plus 7. So we're going to use the power rule to find the derivative here. So we're going to have d over dx is going to be equal to just 4. Because by the power rule, x goes away and then 7 is constant. So we have 4. And then number 4, we have 5t plus 4t squared. So by the power rule, we're going to have 5 plus 8t. That's going to be your final answer. Number 5 is going to be another power rule. So we're going to bring 75 to the front. So it's going to be 75x. And then the exponent is going to be subtracted by 1. So it's going to be 75x to 74th power and minus 1 because the derivative of x is going to be 1. That's going to be our answer there. And number 6 is going to be 7 over 4x squared minus 3x plus 12. So if we find the derivatives, 2 is going to multiply into this fraction. So we're going to have 14 over 4x minus 3. And we can simplify the fraction. So we're going to have 7 over 2x minus 3. And that's going to be our derivative. Now number 7 is going to be negative 2e to the power of t. And if you remember correctly, e to the power, the derivative of e to the power of t or a variable, or like a lone variable, is just going to be e to the power of t. But let's say we have e to the power of 2x. The derivative of that is going to be e to the power of 2x multiplied by the derivative exponent, which is going to be 2. The reason why we just keep it as et over here is because the derivative of t, or the variable, is just going to be 1. And there's no reason to put 1, so we just keep it like that. So derivative of number 7 is going to be negative 2e to the power of t. Since the exponent is just a variable, we're going to have our derivative as negative 2e to the power of t. Now let's move on to number 8. Number 8 is t cubed multiplied by e cubed. Now t is going to be our variable because this is a function as of t. E is a constant, so e to the power of another number is going to be treated as a constant. So e to the power of 3 is probably like I don't want to guess it, but it's probably like 12 or something, or 12. So if we find derivative, we're going to have 3t squared and just that, because e to the power of 3 is going to be a constant and derivatives of constants are 0. And now we're going to have number 9. W is a function of v. We have 1.8 v to the negative power of 3. And so if we find the derivative, we're going to multiply the front. This negative 3 is going to go to the front. So we're going to have negative 5.4 at the front. And we're going to subtract the exponent by 1. So it's going to be negative 4. And you could also rewrite it. If you rewrite it, it would be negative 5.4 over v to the 4th power. But both ways just work fine. And now let's take a look at number 10. Number 10 is going to be dealing with some fractional exponents here. So we have z to the negative power of 5 and minus z to the half power. If we find the derivative using the power rule, we're going to have negative 5z to the negative 6 power. And the reason why the exponent goes up when it's negative is because you're subtracting 1. Negative 5 minus 1 is going to be negative 6. And now we're going to have minus 1/2 z to the negative 1/2 power, because 1/2 minus 1 is going to give us negative 1/2. And we could rewrite this as a function without negative exponents, in which it's going to be negative 5 over z to the 6th power. And that's going to be minus 1/2 and then and the denominator would be square root of z. And this would be your final derivative for number 10. All right, so let's take a look at these questions. So these questions is going to be a case of the power rule. And before I do start answering the questions, you're feel free to pause the video and try it out. And so I'll start answering the questions. So let's take a look at number 3. Number 3, before actually, let's take a look at the product rule. The product rule, if you remember, it's f prime g plus fg prime. Some people also do f g prime plus f prime g. The order you do it, since it's an addition, it really doesn't matter, but I do f prime g plus f g prime just because the quotient rule starts with f prime g. Uh, but you could chart any of them really works. There's no incorrect order. But let's take a look at number 3. So this is going to be f, this is going to be g. So f prime is going to be 8x multiplied by g, which is going to be 2x plus 5. And that's going to be added to f, which is going to be 4x squared plus 3, and g prime, which is going to be 2. And we multiply it out, we're going to have 16x squared plus 40x, and that's going to be plus 8x squared plus 6. And we combine like terms, we're going to have 24x squared plus 40x plus 6. And that would be your derivative for that. And now let's take a look at number 4. So number 4 is going to be a case of a polynomial and a linear function. Or no, on 2 polynomials, but this has 2 things instead of 3. So f prime again, so we're gonna, this is f and this is g, the ones are right. So f prime is going to be 20x plus 7, and then g is going to be 2 minus x squared plus f, which is going to be 10x squared plus 7x minus 2, and times g prime, which is just going to be negative 2x. And now if we multiply all that out, we're going to have 40x minus 20x cubed plus 14 minus 7x squared. And that's going to be plus, we'll do, 7x times, or actually negative. It's going to be, so let me remove the addition sign. Yeah, negative right there. We have 10x squared times negative 2x. It's going to be 20x cubed, and then minus 14x squared, and minus 4x. And now we have a lot of things, so we want to combine like terms here. So we have 2 negative 20x's, so we're going to have negative 40x cubed, and then we have negative 7, negative 14, so we're going to have negative 21x squared, and then we have 40x, and then negative 4x, so we're going to have plus 36x, and then our constants are going to be just 14. And that is going to be our derivative. And now let's take a look at number 5. So number 5 is going to be x cubed times e to the power of x. So x cubed is going to be f. E to the power of x is going to be g. So we have f prime, which is going to be 3x squared multiplied by g, which is going to be e to the power of x, plus f, which is going to be x cubed multiplied by g prime, which is also going to be e over x, e to the power of x, because derivative of e of x is, or e to the power of x is e to the power of x. If we multiply it out, we're going to have 3x squared ex plus x cubed ex. And you could also factor out the e to the power of x, so it would be e to the power of x multiplied by 3x squared plus x cubed. And that would be your final answer, but you could also put this on the top as your final answer because it's a multiplied out version. All right, so now let's take a look at number 6. So number 6 is going to be, we're going to have f as that and then g as that. So f prime is going to be just ex, and the 2 goes away, times g, which is going to be 2ex minus 1, and that's going to be plus f, which is going to be e to the power of x plus 2, times g prime, which is just going to be 2ex. And if we multiply that out, we're going to have 2e2x minus e to the power of x plus 2e2x plus 4ex. So we could combine like terms here. We're going to have 4e to the power of 2x plus 3e to the power of x, and that is our derivative. Now let's take a look at number 7. So number 7, we're also going to use the product rule. So this in the parentheses is going to be our f. E of x is going to be our g, or e to the power of x. So f prime is going to be 6x minus 5, and multiplied by g, which is going to be e to the power of x, plus f, which is going to be 3x squared minus 5x, multiplied by g prime, which is going to be e to the power of x. And if we multiply all that out, we're going to have 6x e to the power of x minus 5e to the power of x. And that's going to be added on to 3x squared e to the power of x minus 5x e to the power of x. And we could actually combine like terms here. We do have two like terms, so if we combine everything, we're going to have 3x squared e to the power of x, and we have 6x e to the power of x, and then negative 5, so we're going to have plus x e to the power of x, and minus 5e to the power of x, and that is going to be our final answer. And what you could do also is you could factor out the e to the power of x, and you could get a polynomial in the parentheses, but you really don't have to do that. And now let's take a look at, actually, let's do number 8. So number 8, we're going to have this as f, and then e to the power of x is going to be g. We could rewrite whatever's in the parentheses, so so we're going to have x plus 2 radical x, which is also 2x to the half power, because that's a lot easier to find derivative of. So now let's use the product rule. So we're going to have, in here, f prime is going to be 1 plus, that's going to be x to the negative half power, because the half carries around, it multiplies by 2, that turns into 1. Now times g, which is going to be e to the power of x, and that's going to be added on to x plus 2, we could write radical x, multiplied by g, which is, or g prime, which is going to be e to the power of x. And we combine everything, or multiply it out rather, it's going to be e to the power of x plus, we could write e to the power of x over square root of x, and then plus x e to the power of x plus 2 e to the power of x radical x. And I believe this would be your final answer. There's not really much to simplify here, so you could just leave your answer like this. Alright, so now let's take a look at our final question, number 9. So we have x over e to the power of x. This is going to be quotient rule. So what we're going to do is, quotient rule is going to be f prime g minus fg prime over g squared. So let's plug in the quotient rule. So we're going to have f is on the top, g is going to be on the bottom. So f prime is going to be 1 times g, which is e to the power of x, minus f, which is going to be x, and g prime, which is going to be e to the power of x. And that's going to be over g prime, which is going to be e to the power of 2x. And if you multiply it out, we're going to have e to the power of x minus x e to the power of x, and that's going to be over e to 2x power. And I believe you can't really simplify from here. You could factor out the top. If you factor it out, it would be 1 minus x, and e to the power of x outside the parentheses. And you could kind of simplify it. You could cross out the top and the bottom. We could real quick do that. E to 2x power. Now, if we simplify it, one of the ex would cancel out, in which we would have 1 minus x over e to the power of x. And that would also be our final answer, but this works just fine. Alright, so I want you guys to try these few questions, so I'll give you guys a minute to try them out. All of these questions are going to involve the quotient rule, or you could simplify it so you don't have to use the quotient rule, but you could pause the video and try them out. Alright, so let's take a look at number 10. Number 10, if we're going to have e to the power of x is over 1 minus e to the power of x, so the quotient rule, we'll write it up here. It's going to be f prime g minus f g prime over g squared. And if we apply the quotient rule, we're going to have f prime, which is going to be e to the power of x, minus, or no, multiplied by g, which is going to be 1 minus e to the power of x. And that's going to be minus f, which is going to be e to the power of x, minus g prime, which is going to be just negative e to the power of x. And that's going to be over or 1 minus e to the power of x squared, and the denominator, we don't need to simplify that out. Let's simplify out the numerator. So we're going to have e to the power of x minus 2e to the power of x, or rather, actually, e to the power of 2x. And we're going to have minus, or actually plus, because two negatives over here, e to the power of 2x. And we're going to have 1 minus dx squared. And you can see we have like terms on the numerator, negative and then a positive, so we just cross that out. Our final answer will be e to the power of x over 1 minus e to the power of x squared. And that will be our final derivative. And now we're going to move on to number 11. So we're going to have 3 minus 2t on the top, 5t plus 1 on the bottom. So we're going to have f and then g. The derivative of f is going to be negative 2 multiplied by g, which is going to be 5t plus 1. The t's just like addition signs. But we're going to have minus f, which is going to be 3 minus 2t, times g, which is going to be 5. And that's going to be over 5t plus 1 squared. And I need to remember not to get confused with the t and plus. But let's multiply all of that out. So we're going to have negative 10t minus 2. And that's going to be minus 15 and plus 10t. And that's going to be over 5t plus 1 squared. Okay, this is a bit confusing. But we have negative 10t and positive 10t, so we could cross that out. We have two constants, we can add them together, so our final answer is going to be negative 17 over 5t plus 1 squared. And that is going to be our derivative. Alright, so let's take a look at number 12. Number 12 is going to be 6u squared minus 5u over u plus 1. So I kind of delete the quotient rule, but by the quotient rule, we're going to have f prime first, which is going to be 12u minus 5, and times g, which is going to be u plus 1, and minus f, which is going to be 6u squared minus 5u, times g prime, which is going to be just 1, and that's going to be over u plus 1 squared. And we don't need to multiply out the denominator, but we do need to multiply out the numerator. So if we multiply all this out, we're going to have 12u squared and plus 12u minus 5u and minus 5. And then on this side, we're going to have minus 6u squared and minus 5u. And let's quickly simplify this out, and then we'll put it all back together. So we're going to have negative 6 and positive 12, so it's going to be 6u squared positive. And we have 12u, negative 5u, and negative 5u. So we're going to have 2u, and then we just have one constant, negative 5. So that's going to be our top, and then on the bottom, we're going to have u plus 1 squared. And that is going to be our derivative. And now let's take a look at number 13. So number 13, we're going to have 5t on the top, and then on the bottom, we're going to have a polynomial. So let's find for f prime again. So it's going to be 5 times g, which is going to be t squared minus t minus 1. I could have also replaced t with something that doesn't look like addition symbol. but minus 5t, and then the derivative of g, which is going to be 3t squared minus 1. And we're just going to put g squared in the bottom because I don't feel like writing that for now. But let's multiply all this out. So we're going to have 5t cubed and minus 5t and then minus 5. And then we're going to have 15t cubed, and that's going to be plus 5t. So let's combine like terms. We have a negative 5t and a positive 5t, so those go away. We have a negative 15 positive 5. So we're going to have negative 10t to the third power, and that's going to be minus 5. And we could actually put the fraction symbol. So we're going to factor out this negative sign to the front of the whole thing. So this is going to be plus, and we can put parentheses around this. On the bottom, we're going to have t cubed minus t minus 1 squared. And that is going to be your final derivative for number 13. Alright, so let's take a look at number 14. So I kind of deleted it by accident, but that's going to be a 5 right there. So let's find the derivative of this. This is the first question we have where the numerator is just a 1, in which the derivative of that is going to be 0. So if we find f prime, that's going to be 0 times g, which we don't really have to write out g, but let's write it out. It's going to be 2x cubed minus 6x squared plus 5. And the reason why we don't have to write it out is because it's going to be multiplied by 0, so it's going to be negligible anyways. And then we have minus f, which is going to be 1 times g prime, which is going to be 6x squared minus 12x. And then on the bottom, we're going to write g squared. And if we multiply it out, all of this kind of becomes 0. So we're just left with negative 6x squared plus 12x. And that's going to be over 2x cubed minus 6x squared plus 5. And that's going to be all squared, but we don't need to multiply it out. So that's going to be our derivative. And now we move on to number 15. So this question represents what I meant on you don't have to use the quotient rule when you can like simplify it. So we have s minus square root of s over s squared. We can rewrite that as s over s squared minus square root of s over s squared. And if you remember, square root of s is equal to s to the half power. And what we can do is when you divide two variables, their exponents get subtracted. So if we simplify this right here, so we don't have to deal with that fractions, we're going to have s to the negative 1 power, and that's going to be minus, so we're going to have s 1 half power on the top minus 2. 1 half minus 2 is going to be negative 3 half. So we're going to have minus s to the negative 3 half power. And now we find the derivative of this. So if we find derivative just by the power rule, we're going to have negative s to the negative second power, and then plus 3 over 2 s to the negative 5 half power. And we can also rewrite that, so we're going to have negative 1 over s squared, and that's going to be plus 3 over 2, and we're going to have s to the fifth power to the square root. And that is going to be our final derivative for number 15. Alright, so I want you guys to try to take a look at number 1 through 6. So for these, you're going to have to use the chain rule. So you could pause the video and try those out. Alright, so let's take a look at number 1. So number 1, we have y is equal to f minus x to the fourth power, and then all cubed. So instead of multiplying it out and then using like the power rule, the power rule, we can just use the chain rule. So this is going to be our inside function. So what we're going to do is carry the 3 to the front. So we're going to have 3, 5 minus x to the fourth power. And that's going to be to the second power because we have 3 minus 2. And multiplied by g prime, which is going to be, g prime is whatever's inside. So the derivative of 5 minus x to the fourth power, which is going to be 4x cubed. And that is going to be our final answer. Now let's take a look at number 2. So number 2, we have square root of x cubed plus 2. We could rewrite that, so that's going to be x to the third power plus 2 to the half power. And now we can find derivative using the chain rule. So we're going to have half. We bring that over to the front. The inside stays the same. And we subtract the exponent by 1, so we're going to have negative half. And then multiplied by a derivative of the inside, which is going to be 3x squared. And if we rewrite this out, we're going to have 3x squared over 2 square root of x cubed plus 2. And that would be your final derivative. And now we have number 3. Number 3, we're dealing with some trig functions here. So we have y equals sine to the cosine x. So first, we're going to find the derivative of the outside, and we're going to make our way inside. So derivative of the outside sine is going to be cosine, and then we're going to have cosine x, that stays the same in the inside, and then multiplied by derivative of the inside cosine x, so the derivative of that is negative sine x. And then we would multiply by the derivative of whatever's inside cosine x, which is just x. Derivative of that is 1. So we really don't need to write it out, but just in case it's not x, it's like 2x or a variable with a constant or multiple exponents, and it's a good rule to know. So that would be your answer. And now we move on to tan x squared. So the derivative of this is going to be, we're going to have x squared as our inside function. So derivative of tan is going to be secant squared, and then in here would be x squared, and it would stay the same, multiplied by derivative of whatever's inside x squared, so we're going to have 2x, and this would be your final answer. And now we have the derivative of e to the x to the half power. So we have e x to the half power. So if you remember, the derivative of e to the power of x is going to be e to the power of x multiplied by the derivative of the exponent, which usually if it's e to the power of x is going to be 1, so we don't really write that. So a derivative of this by the chain rule is going to be e to the x to the half power multiplied by derivative of x to the half power, which is going to be half x to negative half power. So we could rewrite this as e to the x to the half power over 2 radical x. And that would be your final answer. And now let's take a look at our final question, which is going to be e to the power of x plus 1, the cube root of that. So we could rewrite it as ex plus 1 to the 1/3 power. And now we could use the chain rule, so we're going to have 1/3 in the front. E to the power of x plus 1 stays the same. We subtract the exponent by 1, so it's going to be negative 1/3 minus 1, or 1/3 minus 1, which is going to be negative 2 over 3. And multiply by derivative of the inside, which is just going to be e to the power of x. And we could rewrite this, so if we rewrite this, it's going to be e to the power of x over 3 to the cube root of ex plus 1 squared. So it's a little bit messy, but that would be your derivative using the chain rule for number 6. Alright, so let's take a look at number 7, 8, and 9. So all of these are a little bit similar. So number 7, we have this polynomial here to the fifth power. Obviously, multiplying it all out would be very difficult, and then using power rule would be, it wouldn't, I don't really suggest it, but if we use the chain rule, we're going to have 5 go to the front, so we're going to have 5, open parentheses, 2x cubed minus 5x squared plus 4, and that's going to be to the fourth power, because 5 minus 4, 5 minus 1 is 4, multiplied by derivative of the inside, which is going to be 6x squared minus 10x. And that is our final answer. We could kind of just leave it like that. And now number 8 is a great representation of the chain rule, why it's useful. Now we have a polynomial to the 50th power. It's not even a case of I wouldn't suggest it, it's quite literally impossible. or you wouldn't be able to finish it within an hour. But the chain rule makes it a lot easier to finish. So we just move the 50 to the front. So we have 50 open parentheses x to the fifth power plus 3x squared minus x. And then we have it to the 49 power multiplied by derivative of the inside, which is going to be 5x to the fourth power plus 6x and then minus 1. And this would be our final answer for the derivative of number 8. And now number 9 is going to be 5x plus 1, the square root of it. And if we rewrite it, we're going to have 5x plus 1. That's to the half power because it's a square root. Now if we use the chain rule, we're going to make it a lot easier. So we're going to have half in the front, 5x plus 1. And then 1 half minus 1 is going to be negative 1 half. That's going to be multiplied by 5, which is derivative of the inside. So if we rewrite this, we're going to have 5 over 2 square root of 5x plus 1. And that would be your final answer for number 9. Alright, so I want you guys to try number 2 through number 8. So for these are all ln derivatives. But for number 8 as well, it is also ln derivative, but you might have to use another rule to figure out the answer. So you can pause the video and try that. Alright, so let's take a look at number 2. Number 2, we have ln 3 plus t squared. And let's real quick write out the derivative of ln of like x. It's going to be d over dx ln of x is going to be 1 over x multiplied by x prime, which is in this case 1. But in this case, it's not going to be 1 in number 2. So we're going to have ln 3 plus t squared is going to be 1 over 3 plus t squared. We just put the stuff in the denominator multiplied by whatever's inside the ln, which is going to just be 2t. And that would be your final derivative. You could also move 2t to the numerator. And then number 3 is going to be ln x squared plus 3x plus 5. Again, we could do the same thing. 1 over x squared plus 3x plus 5 multiplied by 2x plus 3. And that would be your final answer. And then number 4, we have x ln x minus x. So what we could do here is just use a product rule for this little thing going on here, x times ln x, and then negative x would just be the power rule. So we're using two rules here. So if we use the product rule, it's going to be 1 times ln x plus x times 1 over x, because the derivative of ln x is 1 over x. And that's going to be minus x. And now let's kind of simplify that out. Oh, and x would also be derivative of that using the power rule is going to be negative 1. So now let's simplify out. So we have ln x plus x times 1 over x is going to be 1 minus 1. And that kind of crosses out. So we're left with ln x as our final answer. And now let's take a look at sine ln of x. So for this, we have to use the chain rule. We have to find derivative of the outside and then work our way in. So derivative of sine is going to be cosine. We're going to have ln x in the inside multiplied by derivative of the inside, which is ln x. That's going to be 1 over x. And that would be our final answer. And now number 6, we have ln sine x sine squared x. So this is again, we're going to use the ln and then we're going to use the chain rule. So we're going to have 1 over sine squared x multiplied by derivative of sine squared x, which is going to be 2 sine x multiplied by a derivative of sine x, which is going to be cosine x. You could simplify this and carry this cosine x to the fraction, in which you would have, and the sine x, in which you would have, I believe, cosine over sine times 2. So that would just be 2 cotangent. I believe that would be your answer, right? Yeah, so we would have 2, and then we have cosine over sine, which is the opposite of tangent, so it's going to be 2 cotangent x as your final answer. And now let's take a look at number 7. Number 7 is ln 1 over x. So this is like an inverse sort of. So we're going to have 1 over x multiplied by derivative of 1 over x, which is x to the negative 1 power. So we're going to have negative x to the negative second power. That's the derivative of x to the negative 1 power. And now we could kind of rewrite it. So we could also rewrite 1 over x as a division function because it makes it visualizing a lot easier. So we're going to have 1 over 1 divided by 1 over x. We cross multiply, we're going to have x multiplied by negative x to the negative half power, or negative second power. If we simplify all of this out, we're going to have negative x over x squared, in which our final answer would be negative 1 over x. And now let me make some space for number 8. So number 8, you could see is it's a little bit different, in which you can't use the ln derivative straight away. You kind of have to use another rule, and that rule is going to be the quotient rule. So now, so the quotient rule again, we know it already. The top is going to be f, and the bottom is going to be g. So f prime is going to be 0 times g, which is going to be ln x, minus f, which is going to be 1, times derivative of ln of x, which is going to be 1 over x. And then denominator, we're going to have ln x squared. So if we simplify numerator, we're going to have 0 for all this. This goes away. And then 1 times 1 over x is negative. We have the negative, and then 1 times 1 over x is going to be 1 over x. And on the denominator, we have ln x squared. And this would be your final answer using the quotient rule, and then we use the ln rule. So that would be your derivative for number 8. Alright, so that was basically it for the review of derivatives. There was a lot of questions based on the product, the chain rule, the quotient, and ln functions. The log derivative doesn't come up very often, but it is good to know the formula for it. But the main way to get good at these are writing down the formula whenever you appear or attack the question, and or just practicing the questions. So these are the formulas to remember, and yeah, that's basically it.